Hey guys, welcome back to Math 1. I'm sure you're all excited to be here. I hope everybody had a great spring break, and we're going to try out this new online learning together. So I guess until I figure out a better way to do things, or a more interesting way to do things, this is what I'm going to try. I'm going to go through just a few notes with you, not as many as we'd probably typically go through. And then you'll have an assignment. You can, on the Schoology page, you can print out the page of notes and follow along and fill them out like we do in class pretty much. And you can also print off the assignment there and follow the directions on that. So, try to keep this relatively short. Here we go. Let's see how it goes. So today I'm going to go over something new, and tomorrow I might backtrack a little bit and do some review. But we'll see. So we were doing circles, if you remember, when we left off, and today we're going to look at tangent lines to a circle. And this would actually, I think, not be section C1 like it says here. I think this would actually be like section C.4, if I remember right. Hopefully that's right. And all we're going to do is look at tangent lines. And you might remember a tangent line is a line that intersects a circle at exactly one point on the circle. And that point is called the point of tangency. And we have a theorem about that point of tangency. A tangent line and a radius that meet at the point of tangency are perpendicular to each other. And the fact that they're perpendicular means that they make a right angle. And better than that, perhaps a right triangle. So we can probably use the Pythagorean theorem to figure some things out. So let's see at a couple things we might do with this information. Our first example, we just want to know whether segment AB is tangent to the circle or not at point B. And we've got some measurements on here, and if it is in fact tangent, then it makes a right angle. All right? And if it makes a right angle, then the triangle you see, triangle ABC, would have to be a right triangle, and therefore the Pythagorean theorem would work. So the way we can check to see if this segment AB actually is tangent is by checking to see if this is a right triangle by using the Pythagorean theorem. So I would set up something like leg squared plus leg squared, and I might put a question mark there. Does it equal the hypotenuse squared? And if it does equal, then it is a right triangle because the Pythagorean theorem works. And if it does not equal each other, then the Pythagorean theorem does not work, and it must not be a right angle, and therefore not a tangent line. So if I get my calculator out and I do the calculations, 16 squared plus 30 squared ends up equaling 1,156, and 34 squared also equals 1,156. So this, in fact, they are equal. So therefore, it is a right angle, and because it's a right angle, AB is perpendicular to CB, and therefore AB is tangent line. There you go. If the Pythagorean theorem had not worked, it would not be a tangent line. All right, so that's one thing you could check and see. Our second thing is a little tougher here, and I don't think you'll do this on tonight's homework. I think you'll do it on tomorrow's probably. And that is find the radius of the circle when we have this tangent line and these measurements. And so what you're going to do is you're going to set up the Pythagorean theorem again. But this one's a little bit trickier. So one of our legs here is the radius. It's r. And our other leg of our right triangle is the segment at the bottom here, AB, which is 35. So that's leg squared plus leg squared. And that has to equal the hypotenuse, right? This is our right angle right here. Our hypotenuse squared, which is r plus 25. This is the equation we need to solve, and we have not solved one like this since maybe back in chapter 4. So here's what we need to do. We need to simplify both sides. The left side is pretty easy. 35 squared is 1,225. Let me make sure of that. It is. But how do we square this thing? Do you remember? So squaring that actually means multiply r plus 25 times r plus 25. And so I would need to multiply r times r times 25, and 25 times r, 25 times 25. And if you do that correctly, you get r squared plus 50r plus 625. And now you're ready to solve this. And the first thing you might do is subtract r squared from both sides, canceling out the r squared. And while we're at it, we might as well subtract 625 from both sides. And that gives us 50r equals 600. And if we divide both sides by 50, we get r equals 12. So the radius of our circle must be equal to 12. Alright? Kind of tricky with the r plus 25 squared, right? We only have one other new thing today, and that is when you have a point outside the circle. That would be point A, and we have two segments that are tangent to the same circle from that point. And what we know is that they have to be congruent to each other. So, if B and D are both points of tangency, then you should be able to find x by setting them equal to each other. So you would say something like 4x plus 7 must equal 6x minus 3. And that's pretty easy for us all to solve, right? It'd be 2x equals 10, x equals 5, and we have found the value of x, which is what we were supposed to do. We could verify it's correct by plugging it in. If I plugged it in here, I'd get 30 minus 3, which is 27. If I plugged it in up here, I would get 4 times 5, 20, plus 7, which is 27. It did make both segments equal to each other. Alright. That's it. You can print out the homework and follow the directions from Schoology on what to do with the homework. And we'll talk to you tomorrow.